Okay, so in this video, I want to look at an example of using a differential. And a differential is another way to think about using a linear approximation, derivative approximating a value given, a slope and a point. A differential, the idea is that, it's a really simple concept well, if we know that the derivative is equal to dy dx. If you just multiply this dx over, so the derivative times dx is equal to dy. Here, basically what this says is that if you change, if you deviate just a little bit, by your x, if you change your x by just a little bit, what effect does that have on changing your y? And a differential can help us approximate that. So, finding the fourth root of 15.7, this would definitely be without a calculator. And so let's think about, that's our function is we're trying to analyze the fourth root, or x to the 1/4 power. And 16, like x being 16, like that's a nice number. I know how to find the fourth root of 16, right? The fourth root of 16 is equal to 2. Now, there it is. So, but I'm trying to find the fourth root of 15.7. In other words, I've deviated by -0.3. I'm changing my x, down by 0.3. So then, how much does that change the y? And if I can figure out how much it changes the y by, I would just add that to the 2, because I already know what the 2 is what it should have been if I didn't change. So that's really all it is. So I can figure out how much y changes approximately by looking at the derivative at that value, and then multiplying by how much I change the x by, how much I deviate by. So the derivative of my expression is equal to 1/4 x to the -3/4, and then how much am I changing by? -0.3. Well, again, this is just an approximation of the differential, but it's a pretty good approximation. So we get 1/4, and then this would be like x to the 3/4 as a positive exponent in the denominator, times -0.3, so times -3/10. Now we evaluate 16, because that's our nice number, right? 16. So 16 to the 3/4 power. So that's 1/4. Well, if I do the fourth root of 16, that's 2, and then I cube it, so it's 8. And then times this -3/10. So now I'm getting 1/32 times -3/10, which is -3/320. Now, realize that that's not the answer to the fourth root of 15.7. What that is the answer to is how much did the y change by. So I can say that the fourth root of 15.7 is approximately equal to the fourth root of 16 plus our change in y, which we just found. So what was the fourth root of 16? It was 2, and so we're going to change it by -3/320. So I guess if I think about 2 in the form of 3, as a fraction of 3/20, that would be 640. Take away 3/320, or what is that? 637 divided by 320. Okay. So yeah, like I said, a differential is used to calculate, like, well, how much did the y value change when your x value changed by this much? If you deviate by this much, what impact does it have on the dependent variable?